In this lesson, we'll continue our discussion on big idea number 1. What are equilibria and how are they quantitatively described? And we'll talk about learning target number 5. By the end of the lesson, you should be able to determine if an acid or a base is strong or weak based on its formula. Once you know that it's a strong acid or base, you can describe it using Arrhenius Theory and calculate the following concentrations: hydrogen ion, hydroxide ion, pH, and pOH. Arrhenius theory describes acids and bases by looking at what ions are produced when a chemical is dissolved in water. An acid is a substance that produces hydrogen ions, or H pluses, when it dissolves. A base produces hydroxides, or OH minuses. Both of these processes usually involve an ionic compound breaking apart. So it is described as a dissociation or an ionization reaction. To write chemical equations for these reactions, you break the compound into its separate ions, making sure to include proper charges, AQ states, and then balance the equation. If you're writing an ionization equation for a polyprotic acid, one that contains more than one hydrogen, usually only one hydrogen falls off. Let's look at some examples. If I'm going to write an ionization equation for HBr, I need to know whether it's an acid or a base. HBr is an acid because H is listed first in the formula. This will fall apart and make H pluses, as per the Arrhenius definition. The second piece will be what's remaining. If HBr loses an H1 plus, it will become a Br with a 1 minus. Remember, it's not just an H that you're removing, you're also removing a positive charge. So if I start with a compound that has a neutral charge and I lose a positive, then I will have a 1 minus remaining. I add AQ states to each of my chemicals and check to make sure that it is balanced. Pause the video here and write ionization equations, for example B and C. Here are the answers. Aluminum hydroxide is a base because it contains OH1 minus ions. When it ionizes, it produces 3. That leaves an Al with a 3 plus remaining as the second ion. All of my chemicals have AQ states and I am balanced. H2SO4 is an acid because it has an H listed first. It's a polyprotic acid because there are 2 H's. But as mentioned before, only one H falls off. This leaves an HSO4 with a 1 minus charge remaining. You should also be aware of how Arrhenius theory describes an acid-base neutralization. It does so by describing it as a hydrogen and hydroxide ion combining to form water. This is very different than Bronston-Lowry theory, which we will discuss later. The terms strong and weak are often discussed in acid-base chemistry. Strength depends on how much of the original chemical dissociates or ionizes. The term strong means that a chemical dissociates close to 100%, meaning that essentially all the original chemical has separated into ions. In terms of equilibria, this means that the forward reaction goes to completion, and the reverse reaction very rarely occurs, making the value of K extremely large. This also means that you can determine the concentration of the ions simply by using mole ratios in the ionization equation, because all of the acid or base falls apart. In contrast, the term weak describes a compound that only partially dissociates, leaving some reactants remaining. This means that the forward and reverse reaction both occur. K will be small, and you must use an equilibrium calculation, including an ice table, to determine ion concentrations. There are very few strong acids and bases. They can be identified using the following rules. Rule number 1. A binary acid is hydrogen attached to any nonmetal. Any binary acid that has hydrogen bonded to a halogen, excluding fluorine, is considered strong. Strength increases the further down the halogen is in the periodic table. That gives you only a few strong binary acids: HCl, HBr, HI, and HAT. Rule number 2. An oxyacid is when hydrogens are added to polyatomic ions. Any oxyacid in which the number of oxygens exceeds by 2 or more the number of hydrogens that can be dissociated is considered strong. Strength increases with more oxygens. And rule number 3. All oxides and hydroxides of group 1 and 2 metals, excluding beryllium, are strong bases. Oxides produce hydroxide ions by reacting with water and making 2 hydroxide ions, as shown in this equation. And finally, remember from our organic chemistry unit that carboxylic acids, or compounds that end in COOH in their expanded molecular formulas, are considered weak acids, and amines, compounds that have nitrogens, are considered weak bases. Apply the 3 rules we just discussed to answer example 2 and example 3.